polynomial functions. We're going to be solving one of those equations today, and we're going to start with this example of f of x equals 4 open parentheses x squared plus 1 close parentheses open parentheses x minus 2 close parentheses to the third power. Now we're going to start by solving the power function. In order to find this, we're going to have to look at the leading coefficient, then the x squared, then we're going to have to look at this x with the third power on the outside. This third power is going to be distributed to this x. So we're going to have to put all of them together. So in other words, multiply them. So it's going to be 4x squared times x to the cube, which ends up being 4x to the fifth, because the exponents, whenever they're being multiplied, you add. So that is our power function, 4x to the fifth. Now our degree is going to be the exponent in the power function, which is 5. Now for the end behavior, we're going to go back to the power function. And since our leading coefficient is a positive number and our exponent is an odd number, our end behavior is going to look like this. It's going to go down, up. Now in order to solve for the y-intercept, we're going to have to go and plug in a 0 for every x. That means right here and right here. So we're going to rewrite this in 4, 0 to the second power plus 1, 0 minus 2 to the third. Now, since this 0 is being squared, it's going to be 0. So that goes away. We're end up with 4 times 1. We're going to end up with negative 2 to the third power. Now to solve this, we have to solve this first, negative 2 to the third power. And since it's inside the parentheses, we're going to have to keep that negative. We're going to end up with a negative 8. And then this 4 times 1 is 4. But this is going to be multiplied. 4 times negative 8 is a negative 32. Now for the y-intercept, we always have to write it as an ordered pair. So we're going to write it as 0, negative 32. Now to find the zeros, x-intercepts, solutions, roots, that's all of the names for it. We're gonna have to solve for each x. That means that we're gonna grab this x squared plus 1, set it to 0, and solve. And we're gonna do the following for the x minus 2. We're going to start with x squared plus 1 equals 0. Then we're going to solve it. X squared equals negative 1. Now we're going to have to square root to get rid of that squared. And that leaves us with x equals the square root of negative 1. Now this square root here means that this is an imaginary number. What this means is that it won't appear on the graph. So we don't have to really worry about that number anymore. Now we're going to move on to the next number, which is going to be x minus 2 equals 0. So we're going to solve this again, and we'll end up with x equals positive 2. That is our 0. It's a 2. Now, the multiplicity. What is the multiplicity? The multiplicity is going to be found as the exponent outside the parentheses. So right here we see that it's a 3. Now, since it's a 3, this means that it's going to be a cross with a wiggle, which means that that is how it's going to look on the graph whenever we plot it. So right now the last step step is to graph. So we're gonna graph the 0 and the y-intercept. So let's start with the 0. It's gonna be at 2. And the y-intercept is at negative 32. So let's say that this is negative 32. Okay, so now we're gonna connect these dots following the AND behavior and the cross with the wiggle. So since the AND behavior, we're gonna start going down, then it goes up, then it crosses with a wiggle. And that is our graph.